1.8 million years ago. It's not that long ago. But in the big picture, it is hard to find things. Now, there is a set of fossils of Australopithecus afarensis. It represents, I'm going to say, at least 15 individuals, maybe more. They're called the first family. And so there's like a whole slew of individuals that were in one area. They think that they probably were killed by some sort of disaster, like a mudslide or something that happened where they all kind of got killed at once and then covered up by sediments. But that sort of situation is very rare. It really is. One individual here, one individual there. Until you'll notice we get to Neanderthals. You start finding lots of individuals. And what are Neanderthals doing that previous species probably weren't doing, or that we don't have really good firm evidence for? Purposely burying their dead. And when you purposely bury someone, you put them in that environment that is so good for fossilization. You're putting it below the ground, covering them with soil. So pretty much the only bacteria material available is their own endogenous bacteria from the gut. And that basically breaks down all the soft tissue, which also breaks down with time, but it doesn't break down the bone. It can't be accessed by carnivores or scavengers, and they are essentially in an anaerobic environment and stay there. And as long as the soil is not acidic, the bone can remain for hundreds of thousands of years. So we do have lots of Neanderthal fossils, and part of that's probably because they're more recent, but they're also clear evidence for purposeful burial, whereas we don't really have evidence for purposeful burial prior to Neanderthals. There are some sites like Atapuerca, the Naledi Cave, the Rising Star Cave system from Homo naledi, where they do think there are lots of individuals in these locations, and there have been hypotheses that they're purposeful burials, but they could also be the result of other taphonomic processes, like being washed down the open pit of a shaft cave, like at Atapuerca. That could also explain the patterns there, or some other similar process at the Rising Star Cave system. So what we do now is talk about archaic Homo sapiens. And I am trying to simplify, sort of streamline our process here. So this is how I talk about archaic Homo sapiens. There are early archaic Homo sapiens. Some would call them Homo heidelbergensis, right? And there are late archaic Homo sapiens, and this includes Neanderthals, Denisovans, these groups. Okay? And yes, I do spell Neanderthals without the H. I do pronounce it without the H. And that is because, and actually anthropologists do that. In general terminology, most people spell it with the H and pronounce it with the H, but the correct sort of way to do it is this way. This is how your textbook does it. This is how a paleoanthropologist does it. And that's because, and I'll talk about it in a second, but it's about the root word for Neanderthal, or the root words for Neanderthal in German. Okay? We're going to look at the geographic and temporal distribution, morphological trends, and the culture and technology trends. Right? So I think the textbook, particularly the lab book, talks about early archaic Homo sapiens as Homo heidelbergensis. I don't use that terminology. I try to keep it simple, straightforward. There's a lot of variation. And as I say, I'm a lumper. I like to lump because I think variation is normal. So we have early archaic Homo sapiens from about 700,000 to about 160,000 across Africa, Europe, and Asia. And then we have late archaic Homo sapiens. The group that we know best are the Neanderthals, from about 400,000 to about 40,000, from Europe, southwestern, and central Asia. So, what distinguishes archaic Homo sapiens, both late and early, from the preceding species Homo erectus? So this is assuming that at some point, about 700,000 years ago, there's a speciation event that occurs, and we get archaic Homo sapiens. Notice that Homo erectus continues to exist in certain parts of the world, but we have the spread of archaic Homo sapiens, particularly up into Europe and Asia. But we do have evidence for early archaic Homo sapiens, the earliest from Africa, suggesting, once again, a speciation event in Africa. So like we saw across the 1.5 million year evolutionary history of Homo erectus, where we got increase in cranial capacity, what we see in archaic Homo sapiens is a continuation, but in a much faster pace, an increase in cranial capacity at a much faster pace. So early archaic Homo sapiens, we get cranial capacities from 1100 to 1300 cc's. The modern human average is 1350 cc's, 1350. So we are in the modern human range for cranial capacity. Then with late archaic Homo sapiens, like Neanderthals, we get even larger cranial capacities, 1200 to 1750 cc's. So there are Neanderthals with cranial capacities larger than modern humans. So there becomes a point where actually late archaic Homo sapiens, particularly European Neanderthals, have larger cranial capacities on average than anatomically modern humans like you and I. Right? Maybe sampling error, but that is a fact. So what's going on here is that we go back to 1.8 million years ago, and we've got these early Homo erectus with about 650 cc's. That is including the Dominici from the Republic of Georgia in with Homo erectus up to about 500,000, 400,000 years ago. We've got brain size up to about 1100 cc's. So really long period of time during which we're getting gradual increase in cranial capacity in Homo erectus. Then for archaic Homo sapiens, over a fairly short period of time, we get another dramatic jump in cranial capacity with those early archaic forms at about 1100 cc's, jumping to 1400 cc's by the late archaic Homo sapiens. There's some overlap between the early archaic Homo sapiens and late archaic Homo sapiens. And then you see modern humans there in orange at about 1400 cc's. So 1350, 1400, that is actually modern humans like to the left of 1400 at the 1350. So anatomically modern humans, even anatomically modern humans, are present on the landscape by 160,000 years ago. So overlapping with late archaic Homo sapiens, like Neanderthals, have smaller cranial capacities, so slightly smaller brains. It does not necessarily mean they're less intelligent, that Neanderthals are more intelligent. Brain size scale, head size, brain size scaled to overall body size, and There's also some reorganization of the brain that clearly takes place between archaic Homo sapiens and the evolution of modern Homo sapiens. So what this means is that basically we have this time period between about 700,000 years ago and 40,000 years ago, where we have these species, these individuals, these groups that look a lot like anatomically modern humans, but they have a lot of features of anatomically modern humans, postcranially, and brain size is in the modern human range, which means they could have behaviors similar to anatomically modern humans, but we don't have a lot of archaeological evidence. The toolkit doesn't change until we get to late archaic Homo sapiens. So even though early archaic Homo sapiens have bigger brains, they're still using those Acheulean tools like Homo erectus. Not until we get to late archaic Homo sapiens that we see a big change in the toolkit. Same is true for modern Homo sapiens. It's not until you get to about 100,000 years ago, which again overlaps with archaic Homo sapiens or Neanderthals, that you get a big change in the toolkit. So archaic Homo sapiens are intermediate. They're in between Homo erectus and modern Homo sapiens like you or I. Right? So where do we find early archaic Homo sapiens? Well, the earliest come from Africa, sites like Bodo, Kabwe. We have, again, back to Southeast Asia, Nyangdong, in, again, the Indonesian island of Java. We also have sites like Petrolona in Greece, as well as a number of sites throughout Europe. And we also have sites in South Asia, which is now the country of India, as well as Eastern Asia, now the country of China. So from the earliest that we have are like Kabwe and Bodo. Bodo's from about 600,000 years ago from Ethiopia. Kabwe about 300,000 years ago from Zambia. And you can see that cranial capacity jump has already occurred. They're already over 1,100 cc's, 1,250 cc's, 1,300 cc's, already into the anatomically modern human range for cranial capacity. However, looking at these faces, they don't look like modern faces like you or I have. The big brow ridges, projecting mid-face, not a projecting face like an Australopithecus or a chimpanzee, but a sort of projecting mid-face through the nasal regions. They would have had pretty prominent noses. And this sort of, it's a precursor to what we see in Neanderthals. We have specimens from Asia, like Dolly at 1120 cc's. Again, sites from Java, again, 1100 cc's. So these are estimates, but again, we're seeing a reduction in robusticity relative to Homo erectus, but much more robust than what we see in modern humans. In Europe, we have sites like Atapuerca, where we have about 400,000 years ago. This is a cave site that they actually broke into the cave when they were blasting through a hillside to put in a road. And it was originally an open shaft. So it was like a pit with an open shaft down into the cave. The excavators like to argue that these individuals were intentionally buried. There's also the possibility that, remains were swept into the hole or simply used sort of as a disposal site. Also in Europe, we have sites from France, Germany, and Greece, all dating to that time period, and all with a cranial capacity of average about 1,200 cc's. And the specimen from Steinheim there kind of illustrates how tough life is as a fossil. Things don't come through perfectly many times because of the taphonomic forces and how difficult it is to become a fossil. Comparing cranial morphology, notice the back of the cranium. So here we have on the right, we have Cobway, it's early archaic Homo sapiens with that cranial capacity of 1,300 cc's. And on the left, you have Homo erectus, Chakotay 2, with an 1,100 cc cranial capacity. Note how angular the back of the vault is on Chakotay. Nuchal crest development back there, large brow ridges, right? Now notice you got large brow ridges on the Cobway specimen, but they're nothing when you compare it to what we saw in Homo erectus. So this is what I mean by a reduction in robusticity, right? More rounded cranial vaults and a reduction in general robusticity. We also have the Acheulean tool culture. Same tool culture that Homo erectus is used by these early archaic Homo sapiens. So we have hand axes from Atapuerca and another hand axe from France. This one from France is made from a pretty fine-grained chert, and it's bifacial, which means it's been worked on both sides and has very sharp edges, right? So what we see is that there's a change, bigger brains, right? So more human-like direction for the cranium. Seems like they're getting more intelligent, but they're using the same stone tool culture as Homo erectus. We don't get that technological shift until late archaic Homo sapiens. So early archaic Homo sapiens trends include increased cranial capacity, relative to Homo erectus, into the modern human range, a more rounded cranial vault that's also taller than what we saw in Homo erectus. Homo erectus has that really low sloping cranial vault, smaller brow ridges, smaller nuchal crest, overall less robust cranial morphology, decreasing posterior tooth size, but no major changes in technology. No major changes in technology. So they're intermediate between Homo erectus and anatomically modern humans. Intermediate, the best way to describe their morphology. Now we have Neanderthals. You saw the video about Neanderthals. If you have it, you really need to go see that. So we have Neanderthals throughout Europe, sites throughout Europe, from Spain all the way up to Germany and east to Croatia, to Kazakhstan, and into West Asia, sites that are in Israel, Jordan, as well as Iraq. And this is some of the bones from the original Neanderthal fossil that was found in 1856. It was located in a cave in the Neander Valley. And in German, valley is tall. It was originally spelled T-H-A-L, but the H was always silent. And then in the past, I don't know, 100 years or so, they dropped the H from the spelling of tall for valley. So Neanderthal essentially means Neander Valley, coming from the German. And so scientists have dropped the H from Neanderthal and pronounced it without the H because that is in line with the German language that is the root of this name. Feldhofer Cave is where the original fossil found, and these fossils are not fully fossilized, they're not fully mineralized. A lot of organic material left, and that is why we've been able to do DNA studies with Neanderthal fossils. And you have Neanderthals in Europe, Neanderthals from West Asia, right? And we have a classic morphology of the low forehead, but a really large cranial capacity. The occipital bun is classic. The large nasal aperture and the prominent nasal bone, so the projecting mid-face region, and then the lack of a chin. These are features that we see to some degree in early archaic Homo sapiens, but they're really pronounced in late archaic Homo sapiens or Neanderthals. Right? So you can see this in comparison, roughly to scale, between an anatomically modern human and a Neanderthal. Right? Postcranially, Neanderthals are more robust. They're like stockier build, more barrel-chested. Arms are shorter than anatomically modern humans, mostly due to shortening of the radius and ulna of the forearm. Legs are a little shorter, mostly due to shortened tibiae, so the shortened distal limb segments. So they would have had a stockier build, right, and a more barrel chest. And this may very well be a cold adaptation, or it may be functional based on nutrition. Without adequate nutrition, we tend to see shortened distal limb segments, or it might be a combination of cold adaptation, nutrition, and a necessity for being a very robust, big-boned individual in order to go hunt like woolly mammoths with a spear and walk right up to it and stab it. Okay? Cultural evolution is well covered in the video, so I'm not going to go into a lot of detail on that. But I'll post those slides if you want to see. But interesting, diet based on stable isotope analysis. Neanderthals are definitely engaging in large game hunting, and they are eating a lot of meat. They are right up there. They're in the carnivore region, up there with the carnivores like cats. They're not even, the bears are omnivorous. Foxes and wolves are going to be more omnivorous, but have more meat in their diet. And Neanderthals are basically as far away up in the carnivore section as you can be, which means they were highly specialized in terms of diet, eating a lot of animal protein. A lot of animal protein and not a lot of other foods in the diet. All right? Okay, now go to Canvas. Go to Canvas. There'll be one more.